when we start this first problem, we need to figure out what the transformations are first. So you notice that our parent function here is to the power of x. So everything that's not in there, that is going to be a transformation. So the minus 7 is our only transformation in this case. Now you notice that the minus 7, it is outside of the x. It's not up in the exponent with the x, like up here, but rather just hanging on the end. So that means it's going to be shifting it up or down. And so we know it's going to be a shift by 7. The only question is which direction. And so since it is up and down, remember that minus would move it down. So yes, this will be shifting it down 7. And therefore, that also tells us where the asymptote is going to be, because normally our asymptote is at 0. Well, in this case, our asymptote has been moved down then, because if the whole graph has been moved down, the asymptote has also been moved down. So our asymptote is going to be at y equals -7. Once I have that, then I can worry about actually making the graph. I'll do that in a moment here. I want to go ahead and go over to the next problem first. So the transformations for number 2 here now. You notice that again, 2 to the x is our parent function. The negative out front is my transformation. That means that it is going to be reflecting it across the x-axis. Now, if you want to describe that as saying that it is flipped upside down, that's also perfectly fine. Now notice though that all I'm doing is flipping it upside down. I'm reflecting it. That means the asymptote, which was at 0, is still at 0. All right, so now that I have that, now I can go ahead and scroll up so we can see the rest of this thing. And in each case, the first thing I'm going to want to do is draw in the asymptote. So for number 1 then, I'm going to draw in my asymptote as a dotted line, always as a dotted line, please, down here at -7. Then from there, it's just 2 to the x is my parent function. So you may recall, what's 2 to the power of 0? Well, anything to the power of 0 is 1, which is why we always start up 1 when we make one of these graphs. All right, from there, it's 2 to the power of x. So if I go over 1, I'm going to double that height. And then if I go over 1 again, I'm going to double that height. So notice what I'm doing there. I started up 1, and then I went up 2, because 1 times 2 is 2. And then that 2 gets doubled. So this is going to be 2 times 2, which is going to give me 4. So if I follow that same pattern, I'm going to end up a total of 8 this next time after that. And then I have to double that to know how far up to go next time. So 8 times 2 would give me 16, which, because we moved it down so far, is going to fit. So I'm going to count up 16 from the asymptote. Always remember to be graphing from the asymptote there. If I count up 16 from there, I end up there. Now that's definitely all the points I can fit on the right-hand side. So now I head over to the left. If I'm multiplying by 2 to the right, that means I'm going to be dividing by 2 as I go to the left. And so 1 divided by 2 gives me a half. Half divided by 2 is a fourth. A fourth divided by 2 is an eighth. And at this point, you're probably going to be losing some accuracy in how you're able to draw it. And so go ahead and plot those points. We know that basically everything else here is going to be almost right on top of that asymptote as we go over. So go ahead and now draw the curve that goes through those points. Now I'm going to head over to the right side there, and I'm going to do number 2 now. So the graph for number 2, remember our asymptote is up here at y equals 0. So I'm going to start by putting in my dotted line here at 0. And then I'm going to start making my graph. Now remember what my normal graph would look like. If it wasn't transformed, my normal graph would have a point up 1 at the start, and then I'd be going up 2, and then I'd be going up 4 from there, and then I'd be going up 8 from there. Remember we said that the negative is a reflection across the x-axis. It's flipping it upside down. So basically what that means is going to be the same stuff, except instead of going up, we're going to be going down. So instead of starting up 1, we're going to start down 1. And instead of after that going up 2, we're going to go down 2. And we're just taking each of those points, and instead of going up, we're just going down instead. And the same thing happens on the left side. So instead of going up a half and then up a quarter, we're going to go down a half and down a quarter and down an eighth and so on. And then once we've done that, then we can worry about going ahead and drawing in our curve through those points, because we now have a good idea about where it's all going to go. And so we now have our graphs for those. All right, that leaves us now with those last couple of questions on each of these about domain and range. All right, now let's take a look at our domain and range. Our domain, remember that's our possible x values. We're going to take a look at our first graph here, number 1. And as I take a look at that graph, I notice that it continues going on forever to the left. If I had more graph, I would still have some curve to draw there. As I go to the right, it's going up, but it's also going over. And if I had enough graphing grid, again, I would see it going forever and ever to the right. And so our domain is all real numbers. And that's actually going to be true for all of our exponentials. And so our domain over here on number 2, it's also going to be all real numbers. All right, now the range. The range is definitely not all real numbers, because if I take a look at this graph, I have graph up above my asymptote. And so I have graph all up here, but there's no graph below it. And so then my range is going to be my y values starting at -7, and they're going up from there. But remember that they do not actually ever hit the asymptote. So we do not say it is greater than or less than. We only say that it is greater than, because greater than or equal to, rather, would be saying that it is actually going to be hitting the asymptote. And of course, it doesn't actually hit the asymptote. That's the whole point of an asymptote. All right, next up, we hit our range of number 2. And again, it's going to be a y value. In this case, my asymptote's at 0. Notice that number in the range, it's always going to be where the asymptote is. And so then, in this case, it's going below the asymptote, so it's going to be y is less than 0 for that one. Now we head on to the back side. And in number 3, the first thing we need to do is we need to figure out, okay, what is our actual parent function going to be here? And again, it's going to be the 2 to the power of x. And that's not going to let me see what the transformations are, because that +3, it's not part of my parent function, but the 2 is. So the +3, it's a transformation. Now notice that that +3, it's up here with the x. If I wanted to, I could have put parentheses around that whole exponent, mean the same thing. And so that x +3 is shifting it, because every time you add or subtract it is a shift, by 3. The only question is which direction. It's up with x, which means it's going to shift it in the x direction. X +3, in every function we've dealt with up to this point, +3 has moved it to the left. Well, all those rules are still true. So that +3, it's still going to be moving it to the left by 3 here. And that's the only transformation you have there. So that's the only thing you got to worry about. Now, if I have some asymptote that's normally at 0, so normally my asymptote here is at 0, where would it be in this case? Well, if I take a horizontal line and I slide it sideways, it didn't move up or down at all. In fact, if you take a horizontal line and shift it sideways, it looks exactly the same as how it started. And so because of that, your asymptote has not moved. Your asymptote is still at 0. The only way to move an asymptote is by shifting the graph up or down. All right, and so I'm again going to shift over and do the top half of number 4 before we go down and do the graphs and all that. So for number 4, my transformations. Again, look to see where that parent function is. It's just the 2 to the power of x. And so then, the -1 and the +3 are both going to be transformations. So I have 2 transformations in this case. And they both are addition or subtraction. So they both will be represented as a shift here. All right, so first up, let's deal with the -1. The -1, it's up in the x, so it's going to be moving it sideways. The -1, minus always moves it to the right. So that one's going to be shifting it right by 1 unit. And then the +3, hanging on the end. It is hanging on the end. It's not with x, therefore it's moving it up or down, and plus moves it up. So this is going to be a shift up by 3 units. And notice that there is a number there that's going to be changing our asymptote. If our asymptote only changes when we move it up or down, then it's going to be moved up 3. And so my asymptote here is at y equals 3. Now knowing that, I can now go down and start looking at making the graphs. And the first thing I want to do for each graph, of course, like I've been saying all along here, draw the asymptote. Always want to draw that asymptote in. Yes, dotted lines, dashed lines all the way across. And then for the second, actually no, let's finish off number 3 first, and then I'll go over and do the asymptote for the other one. All right, so I got my asymptote there for number 3. And remember my transformation for this one is a shift to the left 3 units. So normally I'd be putting my first point here, up 1 on the axis. That point, notice, is going to be shifted over. So instead of starting there at 0, I'm going to be putting my first point up 1 still, but now it's over left 3. All right, now that I got that first point in, now I can just go with the fact that it's a 2 to the power of x, because 2 to the power of x means double your heights. That's always what that's going to be telling you to do. So if I just went up 1, I'm going to go up 2, and then I'm going to go up 4, and then I'm going to go up 8. I'm just doubling those heights as I go to the right. Well, if I'm doubling it as I go to the right, that means I must be cutting it in half going to the left. And so then I again go back to where my 1 was here, and as I go to the left from there, I'm going to cut each of those heights in half. So half, a quarter, an eighth, and so on. And then once you've done that, then you can go ahead and draw your curve in. Now I'm going to turn my attention to number 4. First thing I want to do again is to draw in the asymptote. In this case, my asymptote is at y equals 3. So horizontal dashed or dotted line up at 3. Now, we also had another transformation here. We had transformation of shifting it to the right 1. So instead of putting my first point up 1 on the x-axis, or on the y-axis rather, we're going to be going up 1, but over to the right 1. So that is our first point. So you draw in the asymptote first, then you don't have to worry about how far it's been moved up or down anymore, because you drew that in. Then you can worry about shifting it over. Now that we've done that, we're back to just graphing our standard 2 to the x. And of course, like I was just saying with the last problem, 2 to the x means that I'm going to be doubling it as I go to the right. So if I just went up 1, I'm then going to go up 2, then 4, then 8. Oh, 8's off my axis, so I don't have to plot that one. And then as I go to the left, then that means I got to be cutting it in half. I'm dividing it by 2 there. So then I start at the 1, then I go to a half, and then I go to a fourth, and then I go to an eighth, and so on. I got enough points drawn in now to draw the curve accurately, so go ahead and draw the curve now. All right, we are now done with our graphs, and now that we have the graphs, finding the domain and range is a lot easier, because while we, strictly speaking, don't necessarily need the graphs in this case, because we're probably by now seeing all the trends with the asymptotes and all that, it's still easy to have that visual, and that does help a lot. So for my domain, well, they're exponential, so I know the domain for both is going to be all real numbers. That's an easy one, I hope. All right, then the range. Range is not all real numbers, so it's going to be a y value, and it always starts at the asymptote, so it's going to be y, and it's going to be 0 for number 3. And then since it is above the asymptote, that means that it must be y is greater than 0. And that's it, that's done. All right, next up for number 4, the range. Again, it's not all real numbers, so I start by writing down my y. My asymptote is at 3. And then I'm going above it again, so it's going to be y is greater than 3. And that one is now done as well.